All right, hello guys. Today we have a geometry problem, and basically, it's actually a quite easy one, but perhaps it might not always be as easy or intuitive if you're quite new to geometry. So this is definitely not for any advanced students. It's just probably a introduction to geometry and right angles and triangles in a way. Okay. So what I want you to realize before we get started is that what is the question really asking? The question just wants one side, which is A. So find the length of A, and A happens to be here. Fine. And then it has given us three values. So here's the first one, here's the second one, and here's the third one. Let's just realize what they mean. All right, it says B, so B is a side. It's particularly this side. It is 3.45 meters. 3.45 meters. And we also have an angle of 25.3 degrees and another angle of 34.1 degrees. Okay. Before I start, I want you to realize that what we're dealing with. So the whole thing is actually, if you look at it from this point of view, the whole thing is inside a rectangle. And within this rectangle, there are four triangles. We can go by naming them. Triangle number one, which is this one. Maybe I change the color now. For triangle number two, let's call this one triangle number two. And this would be triangle number two. And then triangle number three would be the one in the middle. And then triangle number four would be the one on top, which is over here. Okay, very messy. But anyway, we basically concluded now that there's a rectangle, and within it there are four triangles. Good. Okay. And if we go ahead and actually write the numbers that we actually assigned on these triangles, it will make our lives a whole lot easier. 4. Okay, so we're not going to touch this sketch, but we're going to have another sketch right next to it over here. There we go. Let's just put them right next to each other. So they are the same question, guys. I hope you're not getting confused. Okay, so let's find out a way on how to do this. How to let's basically come up with a plan on how to solve this. Okay, so in order to find A, we would need to focus on triangle number one over here, but we don't know anything about triangle number one besides the fact that this angle over here is 90 degrees. But in order to use SOH CAH TOA and effectively finding the hypotenuse or the sides or angles through the method, you will need to know at least one acute angle, and an acute angle is anything less than 90 degrees. So something like this. So these two will be acute angles. And one side of the triangle. And we'll get into the theory of SOH CAH TOA really quickly, but let's just come up with a plan. Okay, so right now we don't have any of them. So what should we do? Okay, so we do know that we need to find FE. And by the way, there are multiple different ways. I'm just picking one, and this is not necessarily the easiest, but I think it's pretty intuitive. But we will need to know FE. FE is good because it is the hypotenuse of triangle number one, but it is also the base of triangle number two. Okay, so the hypotenuse of triangle number one is the base of triangle number two. Okay, so in order to find, so we can rephrase our sentence. So in order to find the hypotenuse of the number of triangle number 1, we need to find the base of triangle number 2. Okay, so now we are focused on triangle number 2. Forget about the triangle number 1 for the time being. Okay, same case here again. But over here, we actually have an angle. So this is 25.3 degrees. So we can remember that. Good. And of course, this is 90 degrees. Okay. So some of our problem is solved, but we still need one side. And we don't have any side. We don't know this. We don't know this. We don't know this either. Okay. So let's look up. What do we have over here? We can find its hypotenuse. And the hypotenuse of triangle number 2 happens to be also the hypotenuse of triangle number 4. And this is number 4, you forgot, over here. So they should actually share the same hypotenuse. And triangle number 4 makes everything so much easier for us because we actually know its base. Its base is given. It is 3.45 meters. We'll find this side, then move on to find this side. Then we can basically fly back again. Okay. So before we actually get started, and you guys can actually skip this part if you are already familiar with the basics, but let's go through the basics just so that we have some tools to work with when a straight line is split. So when you actually get rid of this line, this straight line that we just drew, the combined angle will give you 180 degrees. And why is this useful? This is because when you have a straight line plane, and then let's say that we have one line coming out at a certain angle, and let's say that we know that this angle happens to be 120 degrees, but we don't know this angle, then it's very easy because the sum of these two angles, so the 122 plus theta, has to equal 180 degrees. So 180 degrees minus 120 has to equal 60. Therefore, theta would be 60 degrees. So that's another property I wanted you guys to remember. Then the last one is the SOH CAH TOA, and then we're good to go. So let's just quickly go over SOH CAH TOA. So the thing to remember from SOH CAH TOA is that sign. So SOH CAH TOA, let's just see what it stands for. It sounds if you have never heard about it, it sounds like a bit of a nonsense. But SOH CAH TOA, SOH stands for sine, opposite side over the hypotenuse. The cosine, C for cosine, equaling the adjacent over the hypotenuse. And finally, the T for tangent, and the O, opposite, and the adjacent is the same again. The A standing for adjacent, opposite over adjacent. Okay, good. Now, what does this really mean? Okay, so if you have a triangle again, let's see if it actually corrected for me. Good. Okay, so if you have one of the sides, let's say that we have angle A, and then we also have angle B. Now, what SOH CAH TOA is saying is that if you, as a person over here, come and stand in the same point of view, if you look at the space from the same point of view as angle A, aka like this, then you may actually apply the SOH CAH TOA rule. Now, how did you do that? So we said, let's go over sine. So sine, so that's opposite over hypotenuse. Okay, so what does that mean? From the angles, let's actually name these as well. Let's see, this is A, this is B, capital for small. From what I'm about to say, next call it small h, not to be confused with height, hypotenuse. So from A's point of view, side A is the opposite to angle capital A. So the opposite side to this angle is this side. Okay. and over the hypotenuse. Hypotenuse is just always the hypotenuse, the longest side of the triangle, which is this one. Okay, so that's A over H. So sine A equals side A over hypotenuse. Now, what about angle B? What about from the perspective of angle B? What if we wanted to write the sine of B? Okay, then we will have to move from here behind B and take a look. Okay, the opposite sign to B happens to be B, the small b. And I'm sorry if this BB is confusing you, but you know, the sides are denoted by small letter and the angle is denoted by a capital letter. Of course, you can change it if you would like to. Oops. Okay, so cosine, that was adjacent over the hypotenuse. Now, what is adjacent? So if you are standing in a plane and there is one wall over here and one wall over here, the wall next to you is called the adjacent wall. The wall opposite to you is the opposite wall, intuitively. Okay, so again, that's why I'm saying it's about perspective. So if we stand here behind A and look, hey, what's the adjacent side to A? It's actually B. That's the adjacent side, right? That's hypotenuse, hypotenuse. So if you were to write the cosine of A, that would actually equal B side B over hypotenuse, right? Adjacent over hypotenuse. But what about side B? Okay, its adjacent side happens to be this side, A. So cosine B would equal A over H. As you can see, you see over here, when we had the sine A, they have kind of, these two have kind of switched places, as you can see. Opposite over adjacent, TOA. Okay, so the opposite side of it is actually A, and the adjacent side of it is B. Therefore, tangent of A equals A over B. Okay, good. So triangle number 4. All right, what do we need to know? We already know that its side is 3.45 meters. All we need to know is one angle. And this angle, I believe, over here will be useful. Of course, we can find it through this angle as well, but I think that would take more work. We already know that this angle, alpha, is 25.3 degrees. And we can easily find this angle because we already know beta, which is 34.1 degrees. So this angle over here, now we're going to try and find it. It's 34.1 degrees plus 90 degrees, which is this angle, equals, that equals 124.1 degrees. And we got to subtract that from 180 because that's the sum of all the angles within a triangle. And that should give us a 55.9 degrees. Okay, so now we established that this angle over here is 55.9 degrees. So that makes our job a lot easier now. Now we just need to find this angle over here. And we can just say 90, which is the sum of all the angles, minus the first angle, also minus the second angle, and the result should be the third angle, which is 8.8 degrees. So let's write it over here, 8.8 degrees. Good. Okay, now that we know that, let's isolate triangle number 4 and let's work on it. So we found out that this side of it is 8.8 degrees. Good. And we know that from the information that this side is 3.45 meters, and this is the right angle triangle, so this is 90 degrees. Okay, what we're really interested in is the hypotenuse, since the hypotenuse is actually shared with triangle number 2. If you remember, triangle number 2 was something like, I don't remember how the shape was, but we can have the shape actually over there. Okay, there we go. As you can see, this side, the hypotenuse, let's write H for it, is shared with triangle number 2. So they have the same hypotenuse. So it's very useful, because ultimately we want to find this hypotenuse, the base, or rather the base of triangle number 2. Okay, so let's get to work. All right, now we must use SOH CAH TOA. And going over here, standing over here, and looking at the angle from this perspective, we have options of SOH CAH TOA, but not all of them are viable. If you take tangent of 8.8, what does that mean? What does that mean? Tangent, TOA, opposite, which is B, over A, and B we know, which is 3.45. But is this useful? We are getting A. I mean, ultimately, of course, we could use Pythagoras theorem, but it's just too long, you know. We're getting A. We don't want A. We want H. We want hypotenuse, okay? So we can forget about tangent for now. So tangent, no good. Oops, tangent, no good. So what about cos? Let's see. Cos 8.8. That will be adjacent. Again, adjacent, we don't know. Over hypotenuse, we don't know. This is not useful. This is not useful at all. So sine is the only option for now. Of course, if you went and looked at it from this angle's perspective, the story would have been completely different. But now, for the sake of practice, we're just looking for from this angle's point of view. So sine 8.8, and sine was which is opposite. Opposite is 3.45. That's good, and hypotenuse is what we're looking for. So what we need to do is take the sine of 8.8. 8.8 times it by the hypotenuse, and that would equal 3.45. And then the hypotenuse can be taken alone by dividing sine of 8.8 by the opposite side. And that should give us a hypotenuse. That should give us a hypotenuse of 22.55 meters. So what do we know? Now we know a lot more. Now we know this side as well. We know this to be 22.855. There we go, meters. Okay, but we're not done yet. Now we need to find the base. So alpha, which was, let's zoom this a bit more. So this over here is alpha. This is the same one. So this one is actually given to us, which is 25.3 degrees. And it is 90-degree triangle over here. So that's fine. That's 90 degrees. And also the hypotenuse we just found out about, which is 22.55 meters. Okay, and what do we need to know? We want the base. We want B. Let's call this one A. We want this one. Okay, and we don't want to be bothered to find, I mean, of course we could find this other angle over here, but that's just not necessary. We can be smart with SOH CAH TOA. And what are we looking for? What do we have? We have hypotenuse. We have hypotenuse. So tan is not useful because that requires opposite and adjacent. And we're not looking for adjacent, and we don't have the opposite. So, all right. If we look at it from sine's point of view, sine, that should work fine. Sine 25.3 would require the opposite side, which is B, and that's what we're looking for, over the hypotenuse, which we have. Great. And with a quick algebra, B would equal sine 25.3 times 22.55, and that should give us, and make sure your calculators are not on radian mode. you would get gibberish. All right, so that gives us 9.64. That's actually a rounded number, meters. Okay, so that's the value of the base. Okay, good. Now we know the base. We're almost done. Pretty lengthy. I mean, it's easy, but as you can see, it's lengthy and you need some attention and patience. 64 meters. Very good. And we are almost done. Now we can forget about the rest of it. Let's paste the problem again. Now we can forget about all the rest. They don't matter really at the moment. Now we can just focus on triangle number. I don't know what number I assigned to it, but here it is. This triangle we need to focus on. And we know this side, we just found out that its hypotenuse is 6.64 meters. And all we need to know now is one side. And we know that this is 90 degrees, okay? I will say that we can just pick this side. We can just try and find this, this angle. And how do we find this angle? We can actually use the line property that I talked about a few minutes ago. See this part? This is actually a straight line, right? And these lines are actually angles that are coming out of this straight line. So if I were to draw it, so we have a straight line like this, and then there is one line coming at an angle, and this is our interest angle. So let's put I for it. This is the angle we're interested in. And there's another angle coming out, and it has this square, which means it's 90 degrees, and it's beta. And the third angle is beta, which is given to us actually over here. The right equation, which is 34.1 degrees. Okay, so remember that we said that a line is 180 degrees, so 180 degrees minus 34.1 degree minus 90 degrees. Guys, by the way, sorry, it's a bad habit that I put degrees. You don't have to, you shouldn't write that. If you're doing the calculations, you should only write it at the end of the answer. Anyway, minus 90, and that should give us an angle of 55.9 degrees. Okay, so that's great. Let's go back to the problem. So now we just found out the interest angle. So this angle is 55.9 degrees. So we write it 9.64 meters, 55.9 degrees, and this is 90 degrees. And what we're looking for is A, just A. Okay, so let's see, from the perspective of this angle, if you use sine is opposite. This is exactly what we're looking for, because this is opposite. A is opposite to this. So let's just, without a doubt, use sine 55.9 equaling the opposite, which is A, this is what the question is asking, or this is what we have done all this work for, divided by the hypotenuse, which we found a few minutes ago, 64. And with a quick algebra, sine 55.9 times 9.64, that will give us an answer of 7.98 meters. Actually, I shouldn't use the equal sign. I should use the approximate sign. So A is approximately 7.98 meters, and that's because I rounded it up. So, all right. Thank you guys for listening, and have a nice day.